This is a lesson on factoring, section 4.3. If you look at the blue handout, which can be found on Canvas, you're going to see that there is a strategy to factor that I have outlined. Number one, you always want to look for a common factor first and use the distributive property to factor that common factor out. Some people like to think of dividing each term by the common factor, but I just reverse the distributive property. So as I look at the expression 2x cubed minus 8x squared, numerically, the 2 and the 8 have a common factor of 2. And then the variables, the first term is x to the third and the second x to the second. So the first term has 3 factors of x and the second term 2 factors of x, and we can't pull out more factors than any one term has. So numerically we have 2 and variably we have x squared as the largest power of x that we can factor out. And so I think 2x squared times what would be 2x cubed, and that would be x. And then I think 2x squared times what is negative 8x squared, and that would be negative 4. And I have now factored out the common factor, and the remaining factor x minus 4 does not factor again. It's first degree. The variable x is raised to the first power. Once you factor out the common factor, the next thing you should always look at is how many terms the expression has. And so I've outlined for 2 terms, 3 terms, and 4 or more terms. Let's start at 2a when we have 2 terms. Right now, you have one rule that you learned back in Algebra 1, which is called a difference of 2 squares. You can, in fact, see the rule here. A squared minus b squared is a difference, the operation, of 2 perfect squares. And if you take the square root of a squared and b squared, that's a and b, and notice the factors are a plus b and a minus b. The signs have to be different so you don't get a middle term. So y squared minus 16 will factor similarly. I do want you to notice that the square root of y squared is y, and the square root of 16 is 4. So it's like a is y and b is 4. So in the first positions, we put y, and the second positions, we put the 4, and the signs, one is plus and the other has to be minus, so that if we do FOIL, we can see that we get negative y squared minus 4y plus 4y, which cancel, and then minus 16. So that's a difference of 2 perfect squares. Then when you have 3 terms, I've shown 3 examples here. What we want to try is what is called reverse of FOIL. And if the first term in the trinomial is x squared, we're going to use x and x in the first positions. And what we put in the last positions has to have a product of 2. But if this sign is plus, then the sum of the numbers we choose has to be 3. I don't care if it's a positive or a negative 3. My signs will take care of that. I actually do the numbers first and signs last. I think it's easier. So the good news is I know 2 times 1 is 2 and 2 plus 1 is 3. So I'm going to use 2 and 1. And I know that my signs, since it's a positive 2, have to both be the same. And the middle term has a term that's positive. So I want these both to be plus. And I can test it by multiplying. X times x, of course, is x squared. Then the outside product is 1x, and the inside product is 2x, both positive to get a positive 3x, and then the last term is positive 2. Let's try the next one. We've got x squared minus 10x plus 21 again, the first position's both x. Now we're looking for two numbers that have a product of 21. And since that's a plus sign, I want the two numbers I choose to add up to 10. Well, my choices are 21 and 1 and 7 and 3. And the good news is 7 and 3 multiply to be 21 and add up to 10. Now, it is a negative 10, and that means since both signs have to be the same to give me a positive 21, they both have to be minus. That way, the outside product is negative 3x when I do FOIL, and the inside product negative 7x, and then I get negative 10x. Let's try the third one. Again, first positions, both x. I want my numbers in the last slots to multiply to be 18, but have a difference of 7. And I actually have three pairs. I have 18 and 1, 9 and 2, and 6 and 3. The pair that has a difference of 7 would be 9 and 2. That means my outside product is 2x and my inside product is 9x. And this time my signs have to be different because it's negative 18. And I want the larger product to have the same sign as the middle term. So I want the 9x to be positive while the 2x is negative because the signs are different. And that ends up giving me a positive 7x for the middle term. So that is three examples where the first term has a coefficient of 1, which tends to be a little easier when you factor. Now let's get a little more challenging. Again, it won't be too bad, but let me come up with some examples here. And I am going to, let's see, let's try 2x squared plus 11x plus 5. And I'll do a second one, which will be a little tougher, 6x squared minus 19x plus 15. All right. So again, no common factor. So I'm going to go to the fact that there are three terms and try a reverse of FOIL. First positions here have to have a product of 2x squared. And that only leaves me with 2x and 1x. The last positions have to have a product of 5, and there's only 5 and 1, but there are two orders. So let's see what happens. If I put the 5 here and the 1 here, my outside product is 2x, while my inside product is 5x, and I need the sum of those to end up being 11. Well, clearly 2x and 5x do not have a sum of 11, so that means the order I have them definitely doesn't work. So I'm going to switch it, and I'm going to put the 1 here and the 5 here. That makes my outside product 10x and my inside product 1x. And the sum of 10x and 1x is 11, so I've got them right. The signs have to be the same. And since the middle term is plus 11x, I want these both to be plus. And so now I'm going to have 2x squared plus 10x plus 1x, which is plus 11x plus 5. Let's try this next one. This is even harder. Why? Because in the first positions, I only have one choice, or I have two choices. I don't have just one choice. I have 6x and 1x, or 3x and 2x. And here's my first word of advice. Go with the pair of factors closest together. It doesn't mean that you're not going to have to change, but more often than not, you get to your final answer more rapidly, starting with the pair of factors closest together. And as you get better at factoring, you can become more selective because you understand what's happening. But for now, I would definitely start with the pair of factors closest together. So I'm starting with 3x and 2x. And then in the last positions, they got to have a product of 15. Well, I have two combinations, 15 and 1 and 5 and 3. I'm going to start with 5 and 3. I'm going to put the 3 here and the 5 here. So my outside product is 15x. My inside product is 6x. I need the sum to be 19, and clearly 15x and 6x do not give me 19x. So I'm going to try switching these, and I am going to put the 5 here and the 3 here. Now my outside product is 9x, and my inside product is 10x. And guess what? 9x and 10x add up to 19. So that's good. My signs do have to both be the same. That's why it had to be a sum. But the middle term is negative 19x. So I want them both to be negative so that it combines to give me negative 19x. How about what is a perfect square trinomial? Well, I don't do anything different because I still have 3 terms. So I'm going to try reverse FOIL. To get 16x squared, I'm going to start with the pair of factors closest together. I had 16x and 1x and 8x and 2x, but 4x and 4x are closest together. And I've got to have a product of 9. It could be 9 and 1 or 3 and 3. I'm going to start with the pair closest together. Now, the outside product here is 12x, as is the inside. And I need, well, I made a copy error. This should be a plus. I had to erase this. So I want the sum of them to be 24. And the good news is now, with me correcting my copy error, it does give me a 24. I do want it to be positive, so they both have to be plus. And that means I actually have 2 identical factors. And when the factors are identical, I can write it as the square of that quantity. And that's why it's called a perfect square trinomial. Because when you do reverse FOIL, the 2 factors are the same, and it can be written as the quantity squared. All right. What do you do about 4 terms? Well, 4 terms, we try what is called factoring by grouping. We group the first 2 terms together, and we look at those and see if we can factor out the common factor, which I can factor out x squared, which would leave me with x plus 1 when I check it. X squared times x is x cubed. X squared times positive 1 is positive x squared. And then I look at the last 2 terms. And it is plus, so I'm going to put plus, and I'm going to factor out a positive 2. And positive 2 times x is 2x, and positive 2 times 1 is 1. And it's important for you to understand, for factoring by grouping to work, these 2 factors have to be the same, which the good news is they are. And so now I can regroup. I can group what's outside, the x squared plus 2 together, since they're both multiplied by the common factor of x plus 1. I don't put a power of 2 like I did above because it's over addition and I'm rewriting distribution. And so since both x squared and 2 are multiplied by that quantity, I'm allowed to group them together and say that sum is multiplied by that quantity as well. All right, finally we get down to step 3, which is always to factor completely. What does that mean? Well, you start up at the top of the list with number 1. You look for a common factor. And so 50x squared minus 8, there is a common factor of 2. When I factor that out, that leaves me with 25x squared minus 4. What you have to look at is the fact I have 2 terms there, and it's a difference of 2 perfect squares. which means it can factor again. This is where we factor it and we take the square root of 25x squared. That means 5x in the first positions. And the square root of 4 is 2. And one is a sum and the other is a difference. So that's my first one. The next one, 6x squared minus 2x minus 8. It appears that there is a common factor of 2. When I pull it out, that would leave me with 3x squared minus x minus 4. I can't stop there because I have to check to see if it's possible to factor the trinomial by reverse FOIL. So if it's going to work, it would have to be 3x and x in the first slots to give me a product of x squared. Going based on what I've said before, the last position should be a product of 4. And if I start with the pair closest together, that would be 2 and 2. That gives me an outside product of 6x and an inside product of 2x. But remember, the difference needs to be 1. That's like a 1. And the difference is clearly not 1. So I am going to go back here and get rid of that and my 2's. And that means I've got to try the other combination, which is 4 and 1. And I have 2 orders, and because order matters, I can switch them. I couldn't switch the 2 and 2 because I would have gotten the same thing. But here, if I put the 1 here and the 4 here, do you see my outside product is 12x and my inside product 1x? And the difference is not 1, which means I got to switch them. Now, of course, if you're thinking before you try this, you might think about whether or not that order would work. I now have the outside product being 3x and the inside product being 4x, and the difference clearly is 1. Now, my signs have to be different, and I do want to have a negative 1, so that means the larger quantity, the 4x, has to be negative, and the 3x positive, since the signs are different, to give me a middle term of negative 1x. Let's try this next one. I can see all 3 terms have a common factor of x. That leaves me with x squared plus 12x minus 36. It should be plus. Again, I had a copy error, so let me put that as plus. And now I'm going to try reverse FOIL, and it would have to be x and x if it factors. And for 36, I would use the pair of factors closest together. And the good news is my outside product and inside product are both 6x, and the sum of those is indeed 12. So that is correct. I do need both signs to be the same, and since the middle term's positive, I want them both plus. Now, that means here, this could be written as x times the quantity of x plus 6 squared, because there are 2 identical factors of x plus 6. Last problem. I have 4 terms I'm going to factor by grouping. So numerically, it looks like I can pull out a 3x squared, which leaves me with 4x minus 7. And for the last 2 terms, it's positive, so I'm going to pull out a positive 2, which also leaves me with 4x minus 7. As long as these 2 are the same, I can factor by grouping. So I'm going to group together the 3x squared plus 2, and I'm going to multiply it by the common factor of 4x minus 7. And I have now factored completely. All right, that was a lot, but factoring can be tough unless you understand those basic principles. This assignment is posted on Canvas, but page 242, 4 to 9 all, 20 to 28 all, 30, 32, and 33. You are to copy the original problem and then show your factors. It doesn't take a lot of room, but that's how I want you to do it, so I can show you when you've gone wrong. All right, hope this helps you if you're home. Have a good day. Bye.